Okay, let's move on. So what we have now is the SSD wired to the shift register and then the shift register wired to the Arduino. I need to also provide power from the Arduino to the breadboards and then have a look at how to assemble the sketch. So in regards to power, I'm going to connect first of all the two breadboards together because I'm doing this using two breadboards. So connect the two separate breadboards together, and what I'll do is, because I've got essentially 8 LEDs, I'm going to use an external power source. So I'm going to plug that into the bottle connector of the Arduino, and from here the power is basically will be passed to the breadboards using the 5-volt and ground pins. Of course, I also need to connect the USB port because I need to upload the sketch from the Arduino, so I can have those two plugged in together. So before I send the sketch, I'm going to connect power. So that's 5 volts, goes to the 5-volt rail, and ground. Alright, so now we are ready to get started with the sketch. As a starting point, I'm going to use a cut-down version of the sketch that I used in lecture 60, the shift registers. So all I'm doing here is I am declaring the shift register pins and I'm turning them into outputs, and I've got the exact same write LEDs method that I used in lecture 60. What I want to be able to do is to send a byte to the shift register where each one of the bits will be controlling a unique, different LED. So I'd like to do something like this. So in my setup method, paste a little bit of code. So I define a byte here, 7 bits, a byte, I call that a pattern, and then I pass the pattern to write LEDs. Now depending on which one of these LEDs is on, I'll be turning a segment on the 7-segment display on or off. So for example, let's turn that into a 1 and see what happens. Alright, so that LED was turned off, and that LED is also turned off. What if I turn that into a 1? What happens next? Alright, that segment also became turned off. So I'm going to turn everything off except for the dot for the time being. So I suspect that the dot is So putting zeros into my byte turns everything on. So I'm going to turn the dot on as well. Okay. So this is a good starting point. What I want to do next is to create an array of bytes where each byte will be representing a digit symbol. And I'll be calling the array to display a number from 0 to 9 onto the SSD. So I'm going to copy a bit of code here. So my sketch now evolves to this. Remove that. So I've got an array. It's got 10 items in it, since I have 10 symbols that I want to display. And by default, it's going to be just that. Basically, all the LEDs are going to be 0. I'm going to update that to also be 1. 1 means that the LEDs are off. Then I need to work out what the bit pattern for each byte should be in order to generate a 0, then a 1, then a 2, then a 3, and so on in my SSD. So I'm going to change that two symbols, and I'm going to start with trying to figure out how to create a 0. Right? So let's upload that and see what happens. Alright, so at the moment the byte at position or index 0 of my array is all ones, so my LED segments are all off. Now remember the designation of the segments have got letters, so this one is the A, the B, C, D, E, F, G, and the dot here is the DP. I'm going to try and figure out which bit controls which segment. So maybe start, in order to have a 0 displayed, I need to have all the segments lit except for G. Right, so I need to figure out which one is G, keep that off, and then keep everything else on. So to begin with, there's going to be a bit of trial and error. What happens if I turn that into 0? There we go. So the first bit of my byte, the first bit from the right, represents the dot. I want it to be off. So I'm going to turn that back into a 1 and check out to see what the next bit does. Right, so the next bit turns on segment C. Alright, so now I'm going to start making a little table. I'm starting to write down a little table. And now I know that the second bit from the right controls segment C. Alright, so I'm going to leave that on because it's going to be part of the 0. Move on to the next one from the left. Okay, so the third bit from the right, turns on the segment D. Right, so I'm going to keep that as well and put it into my table. Next, what does it do? Alright, so the fourth bit from the right turns on segment E. Control segment E. I'm going to leave that because that is also part of my 0. What about that? Number 5. Yep, so number 5 controls segment B. I'm going to leave that as well. Next. Okay, so the next one controls segment A. It's also part of my 0. I'm going to leave it on. Let's check that. What does that one control? Right, there you go. I've got my 0. Right, so that the last bit that I changed controls segment F. The 8th bit. Right, the 8th bit controls segment G. Right, so now I've completed my table and I know which bit corresponds to which segment on the SSD. I'm going to put that back to a 1 since it's not part of the 0. And now I'm happy that I've got a bit pattern that represents the 0 symbol on the SSD. So I can move on to number 1. Alright, so now I'm going to focus on this part here. Now number 1, looking at the segment letters, is created by turning off all of the LEDs, all of the segments except for B and C. Right, so that means that my correct bit pattern for number 1 is this. Right, so this is the C, and this is the B. So update the index, and I'm looking at cell number 1 and send off the sketch to check it. Okay, there we go. Number 1. Finish with that. Let's do one more. Let's do number 2. So now we're looking at index 2. Right, so for 2, I need to keep on segments A, B, G, E, and D, right? And the bit pattern that does that is this. So let's verify. Okay, success. You use the exact same method for the rest. And eventually you're going to have an array that contains bit patterns that allow you to represent all these symbols onto the SSD. Okay, just like that. So for example, let's check out 7. Yeah, 7 works. So the last thing to do with my sketch is to create the counter. So I want to be able to count up from 0 to 9 and then start again back to 0. So it's just a while loop. So I've created a function that contains that loop. It just goes from 0 to car count, which is 10, and then goes, I'll remove the serial prints because I don't have a serial monitor. I don't need that. Yep, just writes the symbols to the LEDs, get the bit pattern from the symbol array, pass it on to the write LED function, wait for half a second, and then move on to the next one. And get inside the loop is to call the pattern, and don't need this instruction anymore. Alright, let's check this out. There you go. In most real-life applications, a single SSD will not be enough. Just to display a clock, you need 4. You can use the architecture we saw in this lecture to daisy-chain multiple SSDs together, just like you learned in Lecture 60. You can also purchase components that contain multiple SSDs, including the controller, usually one or more 595 shift registers. Still, with most of these components, you will need to apply the principles you learned in this lecture. You still need to know whether you have a common anode or common cathode display, and you will need to at least confirm that your symbol array contains the correct bit patterns for the symbols you want to display. If you need to display letters as well as numbers, then you are looking for an alphanumerical display. An example is in this image. These displays are similar to the 7-segment displays we just saw, except they contain more segments and therefore more pins. You can find such displays with 16 or 14 segments, and to drive them you need a larger general-purpose shift register or a dedicated controller, like the MM5450. I will try to create a lecture that will demonstrate how to use the MM5450, although I think that with a little effort you'll be able to work it out yourself. Just remember that this IC is just a shift register with 35 bits capacity and a few extra bells and whistles specifically for LEDs. Working with 7-segment displays is straightforward once you become familiar with the principle of operation and the way which you can interface them to the Arduino. As an exercise, add a second SSD to your circuit, controlled by a second shift register. Wire the second SSD to the second shift register in the same way that you did for the first one, and then wire the second shift register to the first in a daisy-chained fashion like you learned in Lecture 60. Adjust the sketch so that now it can count up from 0 to 99. If you do that, then you have mastered the 7-segment display.